Yes, there we go. We're live. Okay, great. Oh, give me 1 second. I know I pressed the button, but I was actually not. I did realize I pressed the button. Anyway, welcome to the stream. Welcome back. It has been a couple of weeks. I'll get into why I took a break in a little bit. First of all, how has your day been going? Mine has been pretty good. And I'm ready to get back into some game engine programming. It's been a while. I've got a big list of all the things I need to do, but in this stream, we're actually gonna try and focus on a mistake I made like almost at the beginning of starting this engine. And it's such a stupid mistake. It's gonna take a while to refactor some things, but it's not that hard. But I'll show you the mistake in a little bit, and it's a small little boo-boo, but it has a big impact on how we're gonna continue writing this engine. So yeah, we'll get into that in a second. First of all, let me actually do all the good streamer things like sharing the actual stream and stuff. So let's copy that in there. Yada yada yada. Do this, do that. Where is it? Where is it? Where is it? By now I should have these things like figured out, right? Okay, there we go. That one. Boom, on the dot. That's actually the correct tower. Great. Okay, that's closed. That's done. Okay. So first, before we get into the coding stuff, I have been gone for, I think, 2 streams now, 2 weeks. I took a little bit of a break because I joined a scouting summer camp. I was responsible for making sure that everybody on the camp had food. And we might get into story times about that a little bit later on, because, I mean, just out of pure interest, it has some interesting challenges, because you're basically scouting summer camp. The oldest kids there, they're all on just a field, basically. There's nothing there. There's no toilets, there's no kitchen, there's no rooms to sleep in, so you have to bring tents, you have to bring everything else. I had some really interesting challenges, especially because we were like I think 100 people in total that need to be fed, and that has some challenges, problems mostly that we need to overcome, and some of them are really interesting. But we're talking about coding today, and if it comes up, we might just take a break and then talk about that for a bit. But today, what's the plan? Let me check my notes. So yeah, I already told you, I made a big boo-boo, well, small boo-boo, but it has a big impact. So we're gonna try and fix that today. So let me actually go over here. There we go. We should be able to see the code, the writer solution now. And this is the boo-boo. So this is what I did wrong. I included the wrong library. I mean, there's no words for it. So I think if we go to our solution explorer and we go to DirectX 12 binding, so we have an import here. I'm gonna try and import like DirectX GI debug. That actually doesn't exist, so we can remove that. This one, it shouldn't be this. It should just be like this. That one doesn't exist, but this one does. That's the one I need. That's the one I need. So I actually, if we go and take a look at the actual third-party folder, I imported like a whole library here, the source folder. We don't need any of this. We don't need any of this. Let's actually see if there's actually anything in here. No, include directories. Yeah, that's fine. We just need to import. Actually, do we need to do that? Probably, but it's fine. That's all fine, that's all fine. Okay, so yeah, we can just remove this whole source folder. Delete. There we go. Don't need it at all. Oh boy, but this will have some interesting repercussions. So if we rebuild the solution, we'll see like a bunch of things that now break because we were using them from the wrong library and we need to fix it. Okay, so we fixed the include. Now, what all do we need to fix? Let's go to the top one and just work sequentially. Okay, so these C DirectX handles, they don't exist. It's just a normal D312 CPU descriptor handle. That's what we need. So to do that, this is actually, I think, overloaded from render API. So we need to copy this Do I need to do anything else in here? Not at the moment. So we need to clean it up. Basically need to clean it. Okay, not in here. So, okay, that was fine. So this function only exists here, but if you go to the definition, there we go. We need a descriptor handle. And now we actually need to fix some things here, because we need to make a descriptor handle, but how do we make that? Well, we make it by, it's just a pointer. Okay, it's just a pointer. So we need to calculate it correctly, and I don't know how to do that. I did when I found a mistake, but I'm not sure anymore. Actually, we don't need to do any thing like that. We just need to do is render targets. Huh. Yeah, we just do that, and then we can do, because we can calculate it, so we can do render targets frame index, because I'm gonna store the handle. Oh, it's been a while since I coded on Azerty again. Dot get, no, actually, disable my numlock. Boop, and then we can probably put it on there because it will have. Oh god. Oh, we need to cast it. Oh shoot. Does this not know that it's oh no, it knows that's a render target. Shoot, so we'll need to cast it. Okay. No worries, I think I did that before somewhere. Oof, there's a lot of issues here. Okay, there we go. This is what I need. Copy that, go down. Where's my error here? Okay, so let's get that. And then we're gonna go DirectX 12 render target. Which is a DirectX 12 render target. So we're gonna static cast to that. And what are we gonna static cast? U. Go. Boop. We can use U in there, and then we can do boop, and I should get a function in here. It's only get resource, but I can get another function in here because I stored the descriptor handle, right? So we can return that instead. So let's do that. Get CPU handle. And then we're gonna just return this. As simple as that. There we go. We'll figure it out later. Where was I? Render API. Where did you go? There you go. And then get CPU handle. That one fixed. Okay, next one. Range. What is it? A read range is a DirectX 12 range. So we'll make a DirectX 12 range. And how does it work? What does it have? Let's actually check. I should have, yeah, there we go. Size T begin event. Okay, so we have this one. We're trying to replace this one. Oh, I can actually look it up for the other one as well, because we'll need it eventually. But we'll do that when we need it. So we can do range, and that's size T begin end. And what does it call? Oh, we'll just set begin and end. So we can just do that, and then set read range to begin equals 0. And then same for end as well. Now we remove this line. And now we got it. That's it. Actually, let's just do 0, 0, because that's possible. since it's a small struct, I like that more. Go. Whew, okay, next one. Let's actually try and recompile. Let's see what breaks next. Loads of stuff. Still, this one. Okay, rasterize description. We need to make a rasterizer description. So let's look it up. What did it do? When we gave it default, we did this. So we need to make a rasterize description with this. So let's copy that. Let's make our rasterizer description. Let's copy that for now. Well, paste it, I mean. Copy that. Rasterizer descriptor. There we go. And it's not gonna be this one, but it's gonna be just a normal one. And then I should just be able to do this to something like that. And then I can flop that in here. Done. Now I also need to do a blend description. Same thing. Also default, so we're gonna look at what the, oh my god. Okay, what the default does, it does this. Let's hope that has the same kind of layout. Line state descriptor. Copy that there. Okay, that's worse. State descriptor. Okay. Boop, boop, boop. Again, not the advanced version, but this one. Okay, and then could we do some cheeky thing like this? And then go end again and do that. Nice, that actually works. Great. And now we're gonna put the plant state description in here. Another one solved. Great. Recompile. Let's see what more breaks. Okay. Still a lot apparently. 12 errors. Okay, and this is the one I was talking about because we got the render target view. Render API get to. Oh no, this is not the one I'm talking about. We can just do this. That's the easy one. Same here. Let's fix this one as well. It's probably gonna be that one. Let's see what's next. Somewhere I'm gonna make this. Oh. Okay. Move. Not included apparently. Fine. So let's do include, what is the algorithm? No. Memory. Or utility. That's utility. Compile this again. Oh, that seems to compile. It's not what I expected. Great. Okay, so actually let me check render target. We set in the handle. So where do we create this? It's in render API. I'm losing my things here. Game engine, render API, there's 12. There's 12 render API. Somewhere in here there is a function called create render target. What does this one do? This is already correctly. Okay, so we get the descriptor handle, put at start, put the pointer in there. Oh, boom. Seems to be already fixed. Good. Okay, so then if we run this, we should have the same thing we always had, which is hopefully, there we go, triangle, beautiful. Okay, since I want this to be submitted as soon as possible, we're gonna do something a little bit weird and do commit this, and then does it say it's removed on all of these? It should be removed. Boop, there we go. Fixed, including wrong directs library. Commit. Boom, saved, done. Great. Okay. Got all that figured out. Let's go back to our scratchpad, which is the first file in here. Boop, there we go. These two done. What do I also want to do is actually add the DirectX GI, this one, graphics interface debug layer, because this will allow us to see if we got any memory leaks. Very important. Okay, how do we do this? Well, if we go to our render API, we already have a call somewhere in here, initialize I think, where we set up the debug layer for, yeah, we set up the debug layer for this, for the normal DirectX 12. We can also collect memory leaks with a separate object. The only issue is I can't do it in this. Interesting enough. Because, here's the cause. The issue with this is gonna be cleaned up at the same time. So it will still see all the memory leaks in there. Not great. Although I could do some funky things with constructor arguments. But I don't want to. Basically, let's go to our application. So we want to detect memory leaks. We want to start at the very beginning and end at the very end. We can't do this in here because, well, the destruction of this object will not happen. Okay, where is my game? Application. So let's go in here. We make a render API here. That's correct. But what I also want to do is actually, before all of this, before I actually create my window, I want to start doing memory leak detection. Now, I could put it just in render API, I think, because this is initialized, right? So with 12, we could just make a constructor and destructor. We already have a constructor, do it in here. And then in the destructor collect it. Hello, welcome. And then in the destructor, actually, let's just try and put it in DirectX render API and see what happens. So what we're gonna do is inside our render API, we're gonna add a new member, which is gonna be DirectX 12 specific. So it's gonna be DirectX GI debug underscore. Isn't there like a debug layer? Let's just look for debug. DirectX, or is it gonna be an DirectX GI debug? Debug 1, there it is. Pointer. Why do I not find it? This is the correct one, right? Boop. Oh, it is a header that I have not included yet. That makes sense. So let's go for binding. Do that. Boop. There. There we go. And then inside the render API.h. This one. Why am I adding it in this one? That's the wrong one. Shouldn't do it in this one. I should do it in, where's it? Render API, direct 12, U. Yeah, and here, actually it's a top object. I will need to have it as a top object. The top, which will make sense later. So I'm gonna do an ogc debug 1 pointer in direct xgi debug layer. Let's call it like that. Do we put it in a unique pointer? We could. Actually, oh, that's the issue. I can't do one. No, shoot, I can't put it in here. Shoot. Oh, that's gonna be annoying. I need to put it in a separate object. Huh. So here's the issue. Let me. It would be better if I have some pen and paper, but okay. So let me tell you a bit about destruction order. Actually, we can actually let's do some. Well, this doesn't matter. We're just gonna comment it out. Let's talk about destruction order for a second. Inside our unique pointers, which is the managed objects we have, inside this, we're gonna put a print statement. So standard. No. Let me just explain it. It's gonna be way easier. So basically, how the destruction of a class works is at the end, it will try and destruct. Like basically at the end of a program, your memory is not needed. Either you call delete on the object or it will get automatically deleted if it's on the stack. When that happens, it calls the destructor for that object, which is this thing. It does that first. This will make sure that whatever is happening inside here will execute when the object is deleted. After that, it will also destroy all the members. So it will go in order from the bottom all the way back up and destroy every single one of these objects if they're on the stack. Very, very big if they're on the stack. Now, what happens when these unique pointers get destroyed on the stack is they will destroy the data that it manages. How my memory leak detection works with its debug layer is in the destructor of this class, I should call hey. Actually, no, I can actually wrap it. I can make a wrapper for it. I'll make a wrapper for it. Okay, I have found a way to go around. Basically, the structure gets called, then all the stacked objects get destroyed. How this debug layer thing works. Actually, let's implement it this way first. So we got this debug layer. Yada yada yada. Let's implement it here. So we got debug, got the direct directory flags. Also set in here is the debug. What is breaking my foot? There's like a splinter in the floor here. Oh, there is. Okay, never mind. Okay, so yada yada yada. Okay, so I need this one. Oh, hello, welcome to chat. Why do you do equals default to destructor? If you do that, you'll need to define all the 5 member functions, move copy constructor, copy line move constructor. Otherwise, you'll just the default constructor gets generated automatically. I know. I don't need to move copy because if I remember correctly, yeah, I do this. This is my own macro. This will delete, copy, and delete all the move constructors for this object. So and what you're saying, if you put like the destructor there, you will need to implement them yourself. This macro does that for me. So what this does is if I go into it, I'll just specify them all with delete. Perfectly fine, perfectly harmless. I don't need to copy this class. I don't need to move this class. I should be able to copy and move this class. So that's why it works. It's perfectly fine, perfectly harmless. But thanks, good, very well spotted. So what was I doing? Oh yeah, I was looking at this one because I need to make sure that I know how to actually... Oh, there's a function for it. Get debug interface. How quaint. So let's call that one. Where is it called on? Is it on the... Oh, it's just a function. Great. Get debug interface. Perfect. What do we put in there? We put some flags in there, I guess. Flags. Okay, so let's get some flags here. And then we're gonna do an IDP that... Oh, come on. PPV arcs, this one. And then in here, we're gonna do the debug layer. There we go. And now we just need to set up the flags. So the XGI debug flags. I'll need to look up what the flags are, because I don't know. Flags not used. Oh, great. So why do we use 1 then? What does 0 do? Do I have it? Oh, it's probably gonna be in this one. Debug, debug, debug. Oh, no. Debug, 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 debug. It should be somewhere in here. Ah, it's not in there. Okay, let's just do that. What does this one need? Oh, it doesn't say. Okay. This is fine. Flags we don't need, so let's just put a 0 in there. There we go. Done. Okay, so we got this now. And then in the destructor, which I completely already defaulted, but now we're gonna actually use. So we're gonna implement it to later on remove it again. Don't worry, it will make sense. Render DirectX 12, render API write complete. There we go. Inside here, we're gonna, oh, we need to actually start it. So in debug layer, I'm gonna have to start enable. Do we need to specify anything in here? No. And then in here, we're gonna have to debug layer to report live objects. API ID, I don't know what that actually is. So let's actually yoink that. Boom. Oh, Google is so useful. Okay. The global unique identity of the objects are use one of the... Okay, let's see. There should be an all. Yeah. I want to check all objects. And I want to check them with some flags. And the flags are... detail and all, I think I need. Detailed information and ignore internal. Yeah, it's detailed information and ignore internal. So I need this. Flags equals this. Or come on. Or ignore internal. Now I need to know what the actual this one is. I think I need to cast it for it to work. Like so. No, not like that. Let's do a wrong thing like that. That works. And then do that in here. Boom, done. There we go. We have debugging information now. So if we do this, we should now see in our output when we close it that there will be some objects leaking. This is to be expected. Hold on. The debug all flag is not found. Interesting. I have that header. Very interesting. I have it. Unresolved external symbol. That's weird. Uh-huh. Let's just do a rebuild. Yada yada yada. So now will it link properly? No. Weird. I thought it was this flag. Port live objects. Memory management sample. There's a sample. Great. Source. Memory management to CPP. Great. Device state with height. Yada yada yada. Where is it? Oof, it's a very long sample. Create resource and a message load assets. Why? Debug. Nope. Where render UI, render memory. Dude, just give me that. That's not even that. Is it this one? No, there should be a main. Okay, main. App load, app run. Great. Management.h. Do you have the debug layer? You don't. There's the other one. That's project filters. So this framework have the. This has a lot. Plant state. Device. Context. The context might have it. Okay, too difficult. Too annoying to look at. Let's see. Report live objects. Let's just. It's also wrong. XGI debug all. I don't get why it's not linking. This one, which is the correct one. NetX12 lib. GI. Oh, it's the UID one, isn't it? I'm missing the UID one? Yeah, because this is in a different one. This is in DirectX UID, I think. There's like a DirectX UID thing. What's it called? DirectX UID, of course. And let's also do directory there 12. XGI. Okay, and now let's rebuild. So I think it works now because we just had the wrong one. Okay, it's still working, still correct. And now it should be able to find the define and link. Perfect. So I was just missing the UID one. That makes sense. We got all of that. So now if you run it, you should still see a triangle. Yep, triangle is there. But now if we go to our output there, it's nothing there yet. But if we stop the application, you should see, oh no, not like that. I need to close the application. So let me close it. We should get a lot of this, yeah. So we're here, and then a live object, 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 a live object. I know why this is. It's very stupid. It is because it does not destroy all the unique pointers before it calls this, right? So what we're gonna do is we're gonna make a debug wrapper, which will put in a unique pointer, and that will get destroyed. Well, we don't actually need to put it in a unique pointer, but we need to create it correctly. Actually, do we need to put it in a pointer? Yeah, we do need to put it in a pointer, because we can also not have it. Yeah. Technically, we should just do this, but I don't like it. We should just do this. And this will only be there in debug. Right, and then we're gonna make this a unique pointer, but we're gonna make it a separate value, I think. Yes. Separate class, at least. We can actually put it in here. But I like it more if it's a separate file. So we're gonna make a new file for it. We are gonna go into DirectX 12. So engine, render API, DirectX 12. We're gonna create a new file. We're gonna call it DirectX 12 debug layer .h. Yes, and then we're gonna also make a CPP file for it. Yes. And then we're gonna add these to the CMake. So this one, oh, that's not how we should do it. I should put it in here and then open it this way. There we go. And then I should do this debug layer. And then if we advance rebuild this one, we should see it in there. We should now have our debug layers in here. Yeah. And we're gonna put everything in here. So what do we need to do? We need to, first of all, pragma once. Always pragma once. Then we're gonna make our namespace, which is HP render. There we go. Then we're gonna make our class DirectX 12. Oops. 12 debug layer. It's final. C++ only. Yes, indeed. For the moment, at least. I might write some tools in other languages. I might write the editor in C#, because that's apparently how it does. UI does suck at C++, but there's so many ways around it. Don't worry about it, we're not that far yet. Okay, so what do we put in this? Okay, public. Do I want to do anything in here? Yeah, this can be default. That can be default. Do we want DirectX 12 destructor? Where's my key on my keyboard that does it? This one. Linux 12 destructor. There we go. And then delete. Copy and delete move. For that. There we go. And then private will have two members. We'll have the one we put in render API a second ago, this one. Yoink. Paste it in here. Which means we're gonna have to actually also wrap it in a unique pointer, please. Thank you very much. So let's copy you. That way we don't need to destroy it. And now we also need the generic DirectX 12 import, so we can use DirectX 12 functions. There we go. So let's put that HB render DirectX 12 unique pointer of this type. That's that one. And now we're also gonna use the other one, which I only set up here, but actually this one. Don't know if it's a pointer actually. Is it a pointer? Ah, well, who cares? And then we're gonna yoink this. Yoink this. And we're gonna put it in here, which is not default. And this one will also not be default actually. So we're gonna include our debug layer, then debug layer it. Like so, but we also need our namespace. Okay, so what we're gonna do, enable the debug layer. Is it .get? No, actually that should work. Like so. And then this should be DirectX debug. So let's yoink this. Copy. There we go. Throw it failed. I don't want to make that function again. It's a very simple function. Let's just do this. H result res equals this. We're also gonna implement that. There we go. Succeeded, should work. There we go, there we go, there we go. Boom, 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 done. And then at the end here, we also need to implement this one. And that's gonna be the same thing we put in the render API destructor. Just this. Now we can remove this again. And put it back to default. Hello, welcome. So you're gonna be using something else for UI? Yes. I mean, for UI, I've not decided yet. XAML seems like a good option, but it's also finicky and annoying. I'm not that far yet. I'm not worried about it yet. There were some other questions in chat, right? Yeah, is this engine only DirectX 12? Do you have something else? Nope, only DirectX 12, although I am abstracting it. So in the end, if I want to do something else, I have everything from DirectX 12 in a folder. I have interfaces for everything else. So I'll just need to implement all of those interfaces, and the rest of the code should, keyword should, work without too many issues. Other than that, can an idiot learn programming? Yes, definitely. It's all just dedication. It's like learning a language. That's all it is. It's just the more you do it, the more you practice it, the better you get at it. But you can easily learn little things, like little sentences, basically. You just need to put in the time. Okay, this is all done. 8 result error. Yeah, that's all fine. So that's our debug layer done. This is also correct, I think. So now let's, inside our render API where we had our debug layer before, we're gonna add a DirectX 12 underscore debug layer. Do we need to make a stack out of it? Oh, do we need to make a pointer out of it? That's a good question. Render hardware interface? I mean, kind of. It's basically just abstraction. I have a render API. So that I'm working on right now. Okay, so I definitely need the include. Do I put it on a stack that will make it immediately? That's actually not that big of an issue because it's the first thing I do anyway, right? We do get the window, but that doesn't matter. So yeah, that's fine. Okay, we can't just immediately create it. Okay, so there, and then we're gonna do debug layer. And that's all we should do, I think. Inside here, it's only that. Boom, done. Is this project for practice or do you have an actual use for it? Well, the goal is to make a project with it eventually. We're far off from it, so actually make a commercial game with it. Will it ever happen? Who knows? Right now I'm just learning graphics programming. Okay, so hopefully if I did everything correctly, if we open this and we close it again, there should be no more, yeah, there's no more leaks here, which is great. However, to test if it actually works, what I can do is see if I can, well, either I can make a leak, which I'm not that fond of, but what I could also do is just yoink this, put it above here, save, build. What this does is now this object will get destroyed later than this one, so when we report the live objects, it should still be alive. So if I close it, yes, it's still alive. Great. So debug layer, ka-ching, working. Yes, okay. Go back to the beginning, please. There we go. Debug layer done. That was actually all I had planned for today. I thought it was going to take a little bit longer. Great. I mean, I have a lot of things left to do, but that was all I was suspecting was going to be able to do. Great. Yeah, okay, so let's make this a little bit smaller again. So what do we have now? We have a screen, if it opens. God damn, why it is taking so long? Did I? No, okay, it's there. So we got a triangle. This triangle is being created from an application. This application has no idea what it's using, right? There's nothing in here that says it's DirectX 12, which is great. Now the only thing I still need to do is actually, I mean, what was there? I mean, I have a bunch of things, right? Oh, that doesn't matter. This one. I have a render frame. I need to create a render frame. That was the one. Yeah. Currently, how does my render API, how do I actually render? Let's look at that. So what do I do in my render is I set the render target and then I release the render target. This is weird because it actually does not know. Right, so we're gonna make a render frame to do this. Because currently I think if I go in here and then go to the derived one, I can't go to the derived one. Thank you, Rider. Render command list, this one. This is the set probably. Yes, so set render target. How do I get it? I just get the current one. And then how do I release the render target? I get the current one again. It's not what you want to do. How would I do it though? Basically, I think what we want is we want to say render frame start and end. And at the start, we start the rendering. We start the render command list. We set up the render target. Basically what we do here, but the render frame should know what the render target is. And it should keep like it should keep the swap chain basically. I think that's how we want to do it. But for now, let's actually not worry about that one. Maybe let's create like a just like a barrier clause we can create. Oh man, this is the stuff I wanted to have more time for, right? Because I'm not out of it. I'm not out on how to implement it yet. Okay, let's actually take a look at our application again. So now this is one render frame. What I would like to happen is just have a render frame that says start, which is this. Oh, set the render target to the correct one. Then we can render, and then it should do all of this. So this should be one function call. Why is this render? That's weird. What does it actually do? Oh god, I hate this. Oh boy, where's it? Render. This one. Oh, it's just executing command list. Okay. And then presenting it. Okay, that makes sense. What doesn't make sense, however, is having it all with render command list. Especially this set render target function. That's weird. This one, it does so much more than just set a render target. Well, no, actually it doesn't. It does clear it though, which is a bit weird. So I think it's fine-ish. But this resource barrier, we might just want to make a class for. Honestly, I don't know how to proceed with this. Let me give it a minute. Let's think about this. Because the render target is just a resource in a handle, right? Yes. And now we set some stuff here. This is all render target based. Then the release, this is also useless because I'm pretty sure I never used the handle, I just used this. That's just to get the resource. Then I cast it again as well. See if I have a DirectX 12 render frame, I wouldn't have to cast it, I only have to cast it once. Boy, not sure how to do it yet. Interestingly enough. Whoa, that was a massive spike. Interesting. So we got all the things set up for now. See, the issue is here, like 2 weeks ago, I knew what I meant with create render frame. Now I don't. I kind of remember what to do with it, but basically I want all my resources for a render frame, for a single frame to be in one class. But all the resources I can think about is just a render command list, which I only have one of now, and the render target, which I also only have one of now. So to make a render frame at this point seems a bit counterintuitive. I can get away with doing what I'm doing now at the moment, which is just having one render command list, which I don't know how this one happens. Oh, that's just in the application. Oh, that's a bit weird. We shouldn't have this, we should just have a frame. Maybe. I mean, this is also fine for now. I will abstract this eventually. I have plans for this, so for now it's fine. I will leave it as is. So then what else is there? Because, I mean, I need more research before I can continue any of this. I don't want to start on ECS yet, because we need the rendering to be on point. We create also, there we go, the fence class. Not sure, there's something with synchronization that's not correct yet. Barrier class I kind of could do, but I'm not sure which type of barriers I all have. Renderer class, no, I don't want to do that yet either. Yeah, I'm a bit stuck because I need to create like a render frame concept and I'm not sure how to do that yet. I need to think about it. So, unless there's something else in my list I can do. Custom, no, this is on now. This, no, this doesn't work. Maybe it does work now though. Make sure that inherits from unknown. Maybe we can make that work. Let's actually try that. Let's see if we can do that. So basically, I explained this like I think earlier as well, but every single thing that is a direct SolveVD pointer needs to inherit from the unknown interface. So we can actually, instead of using a type name here, we can create a concept. So we can create a type name here, a templated concept here, which is concept is unknown interface, which equals I don't remember if there's a type trait for this. Space off. Is base of unknown known that t value, and then I can actually do v here. Then we don't need this. There we go. We're gonna do concept. We can just do t as a known. Type name template t as a known t. And then inside these, we should find that and replace it with this. Whoops, I messed something up. Oh, I put it in a namespace. Whoopsies. Place all. There we go. Whew, okay. And then I do need, oh, we're still running. Whoops. I do need to check unknown objects where it is. header unknown. That should be included if we do DirectX 12. Why is debug layer included here? It shouldn't be. DirectX 12 binding. What is it? How did I call it? Okay, let's clean up the includes a little bit. There we go. It found it. Okay, and now can we compile? Big question. Can we compile? Probably not. Oh, it is compiling though. I made it work. Great. So now that means that we can only do it with unknowns. So if we try and make it with something else. Wait, I'm doing it this. No, this has a unique pointer to that. Because render API, not H. Yeah, let's just have a default. If I put that in a pointer, it should complain that it's not. Yes, it's not an unknown. Great. Ooh. Big win. That was simpler than I thought it was. I think it's also working because I tried implementing this earlier, but I think because of the same header issue we had before, the wrong library, it also didn't work. Great. But honestly, before we start this, I need to come up with a game plan of what my structure is gonna be. Hello, welcome to the stream. I was just explaining that before I can continue with any of the render API, I need a clear understanding of what I want to do, how I want to render my frame. Basically, I've got all the blocks now. I've got all the things, all the building blocks. Yeah, that's what I meant. I've got all of those laid out, but now we need to be able to put them together somehow and make it in a structured way. Basically, let's actually think this out. Our application, do we want to know that it has a render command list? No, we just want to know it has a render API. Actually, not even that. We just want to know it has a window. And we say render. And that's what this function is supposed to do. But what we can do is say, actually a render frame makes a little bit more sense. But it's still high level to put a render frame. Render view, that's a good name for it. So render view is basically the screen you're gonna see. What we're gonna do with that render view is, technically if we have two players, we will have two render views. So we'll have an array of render views, and for every single one we collect them. Does that work? No. Okay, so basically our application, we do need a render API. We definitely need that. We definitely need a window. The shader and the render command list, definitely don't need that. The shader is temporary. This is just game objects basically. And this will all be in game objects and resources. Resources, like that. These are our APIs, right? So we have that. But what is this one? This one shouldn't be in here, right? We should have something else. I think that's more logical. Because a render command list, we don't even know what it does. We shouldn't, this is too low level in the application. The application should not know about the render command list. The application should know about the view, right? Because that's part of what the application is. It's the view, it's the screen. And then how we draw to that screen, the render view can know. So the render view can have a render command list, it can have render targets, whatever. I think that makes sense. What we could also do is look at it a separate way and say that the render frame is how we look at it. So basically we have the one frame we're drawing at the minute, and that's what the application knows, and then the render frame will just do start, end, and then boom, done. So that's two things I'm thinking about doing. So this should be either render frame or render view, or some combination of both. Now at this point I'm thinking out loud because I don't have a plan on how to continue yet. So if we look at the screen right now, if what we have right now, it might not look like very much. This is basically the same I had in week 2, but it's so much better. So basically, what do we have? So we have this. This is our application. What does our application have? It has a means to draw to the screen. That's the render API. We have the box itself, which is the window. And those are these two things. Then we have game objects in it, which is partially the shader, which is how we draw this, how we call it a triangle. But then this application should not know how to draw. Either the render API should know, or we have some kind of render frame, which says this is the frame. This is how we built the frame. Frame builder makes kind of sense. Render frame still makes sense in my eyes as well, but then the render frame, will it have render views? I'm thinking basically, what if we have split screens, right? Split screen, right? Now we have this render frame, but it'll have two views, one for player A, one for player B. But technically that's just two cameras. Yeah, that's also true. It's gonna be interesting. And then it's just separate render targets that get mapped onto one render frame. But yeah, we need some kind of class to match this. And I will need to think about it in the next couple of weeks, look up some documents, see how other people do it. So I'm not gonna continue with that. Is there anything else we can do today? Let's look at the list of things we need to do. No, because I need this one. Then I need to learn a lot more about fences and barriers to create those two. Oh, the fence, I do know the fence I want to do once we have the render frame, purely because once we have the render frame, we can remove the speed cap basically. Right now I have a limit saying like, okay, at the end of the frame, just sleep for a couple milliseconds before continuing. Because otherwise we just use 100% of our CPU, but with fences, we can actually swap more cohesively, I think. Yeah, I think we're ending the things I can do today. Okay, so that being said, let's save this and say, oh, there's two inversion files. Say added debug layer for DirectX 12. There we go. Boom, boom, boom. 12. Type 12. Oh, let me lock this out. Commit and push as well. And I'm gonna check in my second screen if we actually removed all of these. We got this one and we got this one. So I'm gonna push both. And then inside this, let's check my GitHub and see if it actually removed. I'm not logged in. Shut up. Okay, homebrew engine. So is there a source folder anymore? There's still this. There's no source folder. Perfect. Okay, great. Good news. So that's a little bit more clean. So if you want to know, because somebody asked if it's pure C++, 84% is C++, 11 is CMake, 2 is C, which is weird because I don't know what is C, and then a bit of it is HLSL, which is the one shader. What is C? 0 files, great. So why are you saying it's C? Anyway, yeah, I think as a first stream back, just to ease back into it, I will keep it about this length. An hour is fine. I will do my research next week. I want to have a plan. Actually, I had this in mind for a while as already. I have a drawing tablet. Actually, let me get it out. So I have this drawing tablet right here. And I've been pondering if I can actually set it up so I can have basically like my tablet here or my tablet on that side where I can draw on, and then you can see what I'm drawing on stream, which will be nice because then I can explain things graphically, which will be a lot better than doing it in code. And then we can actually brainstorm a little bit better as well. So that might be nice. That's something to keep in mind. I hope I'll do that by next week. Okay, but yeah, that seems to be it right now. We got our render API set up kind of. It's just a render frame. If we got a render frame, then we can start looking into a renderable class. That would be nice. That would be cool. And if we have a renderable class, we can add multiple renderables. We can actually have 2 triangles. That would be interesting. And then once we got that set up, that's when the fun starts. Then we can look into doing it 3-dimensional. Setting that up. And after that, it's either, I'm actually not sure if we either do loading files or start working on ECS. I think ECS will be a nice break from things. So render cube, and then we have file loading, model files. So just be simple OpenJS for now. But I can also do ECS and set up a rendering system. That would be nice. So that's a plan. That's the to-do plan. Yeah. There's some thoughts in here as well. But that's about it for now, I think. Yeah. I cannot continue with the render frame. I cannot make an informed decision. I will, in between episodes, work on that. I will make sure we've got a plan on how we will render or frame, basically. That's basically what I'm worried about. I'll look into some documentation, see how other people do it, see how maybe even like Unity does it, or some other edges do it. And then make an informed decision on how I want to make my own. But for now, I think that's all that we are gonna do today. Ooh. Yeah, that's about it. Unless there's any other questions in chat, I mean, we got some time, but I mean, I'll give it like a minute and then I'll end the stream basically. Yeah, so let's yeah, I mean, at this point, this has been consistent for the last couple of weeks. Well, last couple of weeks I took a break, but before that, like every single time I was like, I got a game plan. I know what to do. And then it turns out I do not know what to do at all, or I've prepared too little, or what else. Yeah, it's frustrating, but we are continuing forwards in small bits, and I'm very happy with the progress we have. I'm very happy that we're so close finally to getting a second triangle on screen, but it's gotta be for hopefully next week or the week after. Either way, I can promise you that by the end of the holidays, by the end of the summer vacation, we should at least have a cube. That's the goal. having by the end of the holiday, so what's that, like 5-6 more streams, we should have a cube. Okay, that's it. Let me find the end stream button. Okay, so I hope you had a fun time. Hope you learned a lot. Anyway, have another rest. Well, good ending the stream. I can't talk anymore. Okay, so what I was gonna say is, hopefully you'll have another fantastic rest of your day, and I'll see you next week with a game plan, a very structured game plan. Hopefully with a third monitor where I can draw on. That would be nice. And I'll see you there. Goodbye.